Sway, if you want to go next.
Hi there, I'm Sway. I am currently in the structures team within TA, and I'm currently doing civil engineering at the University of Warwick.
Hi, my name is Matt Winterbottom. I am currently with the contact systems team as part of technical authority, and I'm studying mechanical engineering at Newcastle University. I think, Sway, were you going to present first?
Yep, I'll go with that. Perfect. So although it has felt like three, myself and the other year in industries have now just completed our 8th month here at Network Rail. And given that now we have passed just over 3/4 of our time here within the company, this is a good opportunity for us to reflect on our time within the company thus far. So here is a little bit about me. So my name is Sway Patel, and from as young as I can remember, I've always been quite a practical person. You can see in the image on the top left, that's me dressed up for World Book Day in year 4, and we were tasked that day to sort of make something, either 2D, a 2D sketch, or a 3D sort of model of something that is to do with the book that we are currently reading. So I must have been reading something to do with robots, and you can see from that age I did sort of take that sort of keen interest in that as I made a robot out of boxes that was almost the size of me at that time. And from there, that practical nature sort of developed into an interest in architecture as I was quite fascinated in buildings. And after doing physics at A levels, I then began to find a sort of more interest in the feasibility side of it, which led me to study civil engineering now at the University of Warwick. Being 2 years into that and completed almost a year into our year in industries, I've taken part in quite a few different activities, as you can see in the images over there on the screen. So the two of me in a blue helmet, that's me in the second year of university. We were taken out to Lake Districts. That was part of a geotechnical sort of trip, and we were seeing soil and how it's changed over time. And the other images are the sort of visits that we've taken part in the year in industry scheme. Now, since the start of my placement year in September 2024, I have been working within the structures team in CA. And during this time, I've primarily focused on 3 fascinating projects. One to do with the wing walls of bridges, the second to do with metallic bridge fatigue, and the third, degradation and capability modeling of bridges. These topics were entirely new to me, and I was excited to dive into each of these areas, given that I'd not explored any of them beforehand. In addition to my work within the structures team, I participate in regular monthly sessions with the other year in industry students and graduates at Technical Authority. These sessions provide a fantastic opportunity for us to deliver presentations on our respective topics, enhancing our presentation skills and broadening our knowledge across various disciplines. Now, on the evening of the 10th of February 2023, a Great Western Railway train struck debris on the tracks at Yarnton Road Bridge in the Oxford area. The debris came from the wing walls of a brick masonry overline bridge. Upon investigation, it was discovered that the wing wall, a layer built in front of the wing wall for aesthetic purposes, had been concealing fractures and cracks that had developed over time without detection. This prompted the involvement of the company's structures team to address the issue and prevent similar occurrences across other bridges nationwide, given the significant potential risk. I contributed to this project by examining over 50 bridges across the company's portfolio across all of its regions using the Nest platform. My task involved extracting detailed information about each bridge, such as the line speed of the track near the bridge, the orientation of the wing wall relative to the tracks, the roads or the footpaths, and the heights of the wing walls. Now, throughout this process, I kept a mental note of how easy or difficult it was to obtain each factor from um, the assets and assess their levels of risk in the event of a wing wall collapse. This analysis helps identify and prioritize specific factors, which I then included in the RAIB reports. This report, when released, is aimed to provide valuable insights for those in the routes and regions, guiding them on which bridges to prioritize for assessments and renewals, and how to prioritize and how to sort of approach them effectively. Working on this project has been an incredible learning experience, teaching me a great deal on sort of technical aspects of bridges, potential risks, and the efficient approaches that are used to address these sort of issues. All bridges and other structures will inevitably degrade over time, and given the great number of bridges in the company's portfolio, it is key to track this with a tool. From December 2024, I have been contributing to the development of the degradation and capability model. This model aims to help identify the condition a specific bridge will be at given a specific time. The benefit here is to effectively structure the priority list for future asset renewals. I've I've been contributing here by feeding inputs such as the latest asset condition, capability information, BCMI condition, etc. into the model by collecting it from the CP6 and CP7 workbanks with the support of asset engineers helping me to locate it within the workbanks and delivering this information to those in the renewals team working on the model itself. This has been great in developing my confidence and team working skills, as I've been working with two parties both outside of the structures team, who I would normally be familiar with, where I'm delivering in a group, where I'm delivering stuff to a group entirely on my own. I recently took on a new project focused on metallic bridge fatigue. McDonald's, who we've been working alongside, has been developing an assessment tool for structures here, for the structures team here at Network Rail to use. And I had the opportunity to be the first person in the company to trial this tool. Now, my role involves testing its functionality and identifying any limitations that need to be addressed. I began this project in February this year, and it has required a significant amount of technical knowledge, not only in assessments, but also in understanding specific topics like metallic fatigue and the workings of a U-frame in bridges. Most of the efforts that I've put in for this project have been towards understanding these concepts before I actually began doing anything towards the tool itself. As I started feeding the tool with information from bridge assessments, I encountered challenges in finding the correct data to meet the criteria and locating this information. These obstacles have slowed down the process of the project. And despite these challenges, I've developed strategies to overcome them, such as creating a systematic approach to data collection and verification. Despite the slow pace, I thoroughly have enjoyed the process so far, and I feel like I will continue to. This project has been incredibly educational, allowing me to learn extensively and develop problem-solving skills independently. Since I'm the first person in the company familiar with this tool, I often have to find solutions for questions on my own. Looking ahead, there is still much more to be done in this project. I aim to further enhance my technical understanding of metallic fatigue and bridge assessments. My goals here are to strengthen my knowledge to the point where I am comfortable in identifying issues or limitations to do with the tools based on my own understanding. This will not only benefit the projects, but also support my studies when I return back to university for my final year. During my time at the company, I, alongside the other year in industry students and graduates, participated in numerous site visits across England. These visits allowed us to observe various projects across multiple disciplines within the company. These visits included the National Railway Museum, the HS2 tunnel construction in London, tours to the Waterloo and Birmingham New Street station, and one that I found particularly fascinating was the visit to the Shrewsbury signal box. At Shrewsbury, I was intrigued by how the staff managed signal changes and communicated with train operators using Morse code. Their ability to comprehend the complexity of simultaneous activities and execute the tasks efficiently both surprised me and interested me. This experience was really has really increased my enthusiasm to explore more aspects of the company beyond my discipline. Another visit I undertook with a member of the structures team, my colleague Daniel, was to the Lake Districts, where we inspected 5 assets as part of the third engineering verification. Our objective was to visually assess whether the examinations conducted by the regional team accurately reflected the actual condition of the bridge. During the visit, Daniel provided valuable insights into coastal defences. He explained things such as strategies, including the types and sizes of rocks, stones, and boulders used in coastal protection. This hands-on learning experience was incredibly informative and broadened my understanding of the practical applications of engineering principles. Furthermore, the Year in Industry scheme has been incredible in providing opportunities for us to develop our interpersonal, organisational, and management skills beyond our respective teams. The experience I enjoyed the most was organising and hosting a work experience week for Year 12 students to explore engineering within Network Rail. Although it was just a week-long event, it required extensive planning over a month in advance. This included scheduling senior engineers from each key engineering discipline within the company, such as signalling, buildings and civils, track, and contact systems. In addition to coordinating these sessions, I designed projects for the students to work on throughout the week. They continuously added to this project, applying the knowledge that they gained from each of the sessions with the senior engineers. The senior engineer presentation significantly enhanced the students' understanding of engineering within the industry. The project was particularly effective in improving their application skills as it allowed them to demonstrate their strengths and identify areas where they needed further assistance, which I then provided. At the end of the week, the students compiled everything that they've learnt and the result of their projects into a PowerPoint presentation. They presented this to an audience of the Year in Industry students, which helped them develop their presentation skills and provide them with a comprehensive slide deck of all the information that they had learned over the course of that week. The outcome was brilliant as the students showed a lot of excitement and appreciated each day. Their genuine interest in each activity they undertook was truly rewarding to see. This made me want to contribute to more activities like this to further both my development and that of the students. I have had a fantastic time at the company so far. Each step has presented its challenge nonetheless, but I've learned so much from each experience. This has fueled my desire to take on more opportunities and continue with current projects to deepen my understanding of both theory and practical application. Moving forwards, I have planned some on-site visual examinations, as these hands-on experience will help me solidify my understanding by allowing me to see things firsthand rather than just from the office. Additionally, I'm eager to take on more responsibility within the East region, who I've been working with just once a week, by taking on larger projects instead of smaller day-to-day tasks, which I'm currently doing. I aim to better my understanding of what the differences are between technical authority and the regions. Thank you.
Brilliant. That was great, Sway. Who are you handing over to now?
We'll hand it over to Shukri.
Perfect.
All right, thank you.
Yeah.
Thanks.
Thanks, Sway. Let me just upload my presentation. Are you guys able to see that well?
Yep.
Cool. Okay. So hi, my name is Shukri. I am a civil engineering student at Loughborough University, working towards a BEng, as I've said. So over the past year, I've had the fantastic opportunity to have my placement with Network Rail, where I've worked in the track and S&C team. My team focuses on track systems within the track and S&C team, which are very key to the operation and safety of the railway network. Fun fact about me is that I am a chemistry enthusiast. I love chemistry. I used to study it in my free time. Don't get a lot of free time anymore, but that was a passion of mine. One of the reasons why I got into civil engineering is because my dad is a civil engineer, and I thought, how hard could it be? If he could do it, why couldn't I? But yeah, so that's a bit about me. So this was at the start of the year. The first picture is when we, the year in industry students and grads, we went to Milton Mowbray to the RIDC Centre, and we got to see some of the new fleet trains being made, right there. We got to have a look around, and I think it was our first time wearing PPE, which was a very surreal moment. I felt like a real engineer. The second picture is that was the first time I went on actual track. So it was like a last minute thing. So some maintenance engineers had some issue with a lot of noise being generated at this section of track whenever a freight train would pass over. And it would really disrupt a lot of the locals in their houses, and the noise was very loud. And I was told that it was going to be loud, but the level of loudness that it actually was yeah, it was it was a bit too much. So it turns out there was an issue with the friction solvent being disposed onto the rails, and it was only putting the friction onto a certain section of track instead of distributing it across. So that was the main issue that we went about. One of the guys actually said, okay, this is probably the main cause, because the other team members couldn't figure it out. But yeah, that was very interesting experience. The next picture is when I went to an OLE training site with Matt. I think Matt would tell you about that too. But yeah, so we had some basic OLE training, and it was very much emphasized on the importance of communication between people who are on track and people in confirming when you turn off and turn on the supply of electricity to make sure that everyone is safe. So at the start of the year, I did take some time to understand track terminology, what the team does. I got sat with different members of different teams, and they really explained to me all of the abbreviations, what the team specifically does, what the end goal was. Well, not really end goal per se, but what everyone's day-to-day tasks were, and how they went about to achieve Network Rail's key, sorry, I forgot the word, to Network Rail's key attributes, what the company wants to do. And yeah, we also had a team away day a few weeks into when I first joined. So it was just meeting everybody and listening to what their issues were and understanding the importance of team collaboration. Here are some trips and visits that I've managed to go on. So throughout the year, I was lucky enough to go on several educational and inspiring trips. Each gave me a unique perspective on how railway operations and maintenance are handled in different regions. So I did get a chance to go on the new measurement trains, which is to do with track geometry. And it was really interesting seeing how, as the train goes by, it's accurately producing data based on the track that we'd be passing over, and it would show us the different faults and to what level each fault was visible on each section of track. I also got to go to Birmingham New Street and London Waterloo for in-depth tours. We got to go into the restricted access areas, so we went underground into different tunnels, and it was a very cool experience. We got to visit the Victoria Channel box for HS2. It is massive. It was a really big tunnel. I remember being told that people go into the tunnels, they have to go quite down, deep down into the tunnel, and they'll spend like a 12-hour shift in there and come out 12 hours later. And I thought that is serious dedication. It just shows how hardworking people are. Again, from what Sway said, we did go to the mechanical box in Shrewsbury. We all got a chance to pull the levers and see how it was doing. The levers are very, very hard to pull. Do not underestimate them. But yeah, that was all really interesting. So some work and tasks that I've done. So I started off the year by learning about product acceptance and the process of acquiring it. So this is a critical process that ensures any new product, whether it's a new sleeper material or fastener, meets Network Rail's strict safety and performance standards before it's deployed. I also reviewed standards to understand the criteria that products need to meet. This involved going through some technical documentation, test protocols, and some approval processes. And touching on the sustainability theme at Network Rail, I have been doing some research into sustainable alternatives for traditional concrete sleepers. So we've been organizing with some companies with a company in Europe which are manufacturing thiocrete sleepers, which are made out of a sulfur material, to be tested in the UK hopefully soon. So that's something that I've been working on. That's one of my main projects. Another task is I worked closely with other manufacturers on screw testing. So we looked at how different screw types respond to stress, weathering, and operational forces, which is vital for long-term track performance. And I got to create a derailment report on a past occurrence, which was really challenging because it's a lot different to what I do at university. And I had to look into possible causes such as screw failure, material fatigue, and installation issues. It's a real-world application of engineering analysis and risk management. Some challenges that I've faced at Network Rail. So coming into a new professional environment was very intimidating for me. I was surrounded by a lot of experienced engineers, and I quickly had to adapt to how things are done. One of the biggest challenges was presenting to different audiences. So whether it's peers or senior staff or external stakeholders, I had to learn how to tailor my communication depending on who I was speaking to. The technical nature of my work as well meant that I had to be precise and methodical in my thinking. And I think the most valuable challenge was learning how to collaborate on larger scale projects. It really gave me an appreciation for how complex and interconnected the railway system is. Some takeaways are, so one of the things that stood out to me the most was how collaborative and supportive the work environment is. Despite the scale of seriousness of the projects, there's a real sense of teamwork and openness. I learned not to be afraid to ask questions, no matter how basic they may seem. I think everyone started somewhere, and so asking the right questions helped me develop faster and avoid mistakes. I also learned that acronyms are everywhere in the rail industry, and they can often mean completely different things depending on the context. So this taught me the importance of always double-checking terminology and keeping clear documentation. This placement has really confirmed for me that I want to stay in the railway or railway infrastructure sector, particularly in track engineering. I think the variety, scale, and impact of the work is something I find rewarding, and it's helping me learn a lot more. Right now, I'm exploring track-related topics for my dissertation for when I go back to uni, and I am aiming to deepen my technical skills, including calculations and learning different engineering software that's used in track design. Overall, this experience has shaped my career goals and has given me the confidence and clarity to pursue a future in rail engineering. Thank you so much for listening. Yeah, Matt, I think you're next.
Yep, no problem. And you all see that okay?
Yep, we can see that.
Yep.
Cool. So my name is Matt Winterbottom, and this is a little presentation about my time at Network Rail. I do apologise, it's quite a lot wordier than the last two, and I do a bit of a deeper dive into one of the projects I've been working on. So a little bit about me. I study at Newcastle University. I love it there, and I would love to stay up there after uni if a job permits it. I've completed stage 2 of a bachelor's in mechanical engineering, and I'll be going back in September to start and hopefully finish stage 3. That is the Stevenson building, which is a brand new engineering building for Newcastle University. It's a really nice building. Spend most of my time there. My primary career aspiration, would be to work in Formula One as part of a pit crew or engineer team. I've been into Formula One for around 4 years now, and I'm quite a big McLaren fan. I wasn't massively interested in trains before I started at Network Rail, but now I am a bit of a fanatic. My favourite one is the Mallard, and I'm very interested in all of the fleet trains as well. So my time at Network Rail so far, I work in the contact systems team in TA, predominantly working with OLE. I have met lots and lots of new people, including Mr. Haynes, along with some of the other year in industry students. We were down in Waterloo and he had a free hour, which is very unlike him. So we managed to secure a slot with him there, which was really insightful. Lots of interesting trips. So we visited the HS2 site and at Old Oak Common, like Sway and Shukri have said, and obviously the Seven Bridge Junction signal box in Shrewsbury, which was really cool to see. Here are some of the things that I have done with my time at Network Rail. So, as Shukri said, we went to Walsall to do some OLE bespoke training. We learned about communication between line side and the ECR, how to handle isolations and how to apply and remove earths. Nominated person electrical safety training material. So me and my colleague Aaron Brandrick updated the previous training material to make it more accessible to those who were undertaking it. And as I was a fresh set of eyes, it was quite handy for me to be in the same position that those who would be taking it. Design for reliability. I learned about what goes into to design a product to allow it to be used on the railway for extended periods of time. Ingenuity 2025. While this probably isn't directly related to Network Rail, we are doing it through Network Rail. So it's a competition that me and a few of the other year in industry and grads have entered. And we're tasked with running an engineering company and trying to become the top company in the world. The new leaderboard was published today, and we are, I think, in 89th out of 115. So we're not very near the top, but we are not last. So that is a positive in my eyes. And then this is the project that I'm going to do a little bit of a deep dive on, is the carbon cost of electrification. It's been pretty much the majority of my last 3 months here. Shukri and Sway will be bored of hearing about it, but I'll go into quite a lot of detail on it now. So a little bit of an overview of the carbon cost of electrification. So as the UK approaches its net zero goal of 2050, reduction of railway emissions play a crucial role. The railway emits 1.4% of UK transport emissions and 0.5% of total UK emissions. Travelling by train emits 3 to 5 times less carbon than driving per person per kilometre, around 6 times less carbon than flying per person per kilometre, and a single freight train may be able to remove up to 70 heavy goods vehicles from the roads. Electrification could be a real solution to this net zero goal, and the objective of this study is to analyse current carbon emissions of electrification and explore opportunities to reduce this. So initially, I researched the plans and strategies of rail-based institutions and organisations. So this came from the RAA, RSSB, DFT, the TDNS at Network Rail, Transport Scotland and Transport for Wales. All of them are committed to net zero and have action plans to achieve this by 2050. However, Transport Scotland have plans to achieve net zero by 2045. All institutions mention electrification as a primary contributor to net zero. Some mention hydrogen power, the complete removal of diesel trains by 2050, and battery power to achieve multimodal optimization. So the scope of the project covers 80 single track kilometres of open route UK Master Series overhead line equipment. All assets are included within the diagram, such as feeder stations, overhead line cabling and sectioning locations. There is also an assumed need for 40 kilometres of vegetation clearance, 40 kilometres of Ethernet fibre optic cabling, and 33 bridges that need to be taken into account. Of these bridges, it is assumed that 11 need no work, 11 need track lowering, and 11 need rebuilding, 1 4-lane bridge, 2 2-lane bridges, 4 foot bridges, and 4 farm user bridges. Grid connections weren't included in the study, as there is quite a large variation of carbon emitted depending on the distance between the connection point and the line side. For instance, a grid connection 5 kilometres from the line side would emit significantly more carbon than one that was only 500 metres away. Then I used PAS 2080, which is a whole life carbon management strategy provided by BSI. It splits carbon emissions into modules, which have sub-modules within them. Module A is the before use stage, so modules A1 to A3 are the production, module A4 is transport to site, and module A5 is construction once on site. Module B is the in-use stage, B1 to 5 are use, maintenance, repair, replacement, and refurbishment respectively. Module C is the after use or end of life stage, so C1 to C4 are demolition, transport, waste processing, and disposal. Emitted carbon for each module is calculated through the WLC baseline tool, which we'll have a look at now. So the WLC baseline tool is a spreadsheet created by Expedition and checked by Ruth Thomas, worked to the 80 single track kilometre scope. It analyses each asset by module to calculate the total carbon emitted. Each module has been calculated based on well-rounded assumptions with data from the rail carbon tool provided by Bath University. It can be used to obtain a total emitted carbon value for 80 single track kilometres, which is nearly 39 million kilograms of carbon dioxide. That would take far too long to read, I think. These are the findings from the baseline analysis. So the main areas of carbon dioxide emissions are route clearance and OLE supporting structures, due to such a high amount of metalwork that is required to sort of build them. Over 90% of total emissions are from these two areas, meaning that they have the highest potential for reductions. So this was the first scenario that I looked at to try and reduce the carbon emitted by electrification. So route clearance is the biggest carbon cost of electrification. And in the baseline, it was assumed that tracks are renewed and when they're lowered, when they probably don't need to be. If tracks are reused instead of renewed, there is an estimated carbon reduction of around 2.9 million kilograms of carbon dioxide, which is approximately 25% of all carbon emitted by route clearance. This was the second scenario using discontinuous OLE. If it is used in an assumed ratio of 3:1 electrified to non-electrified, 25% of OLE supporting structures and OLE wiring can be removed. This gives a decrease of around 4.1 million kilograms of carbon dioxide in the OLE area. So properly planned electrification. By properly planned, I mean taking into account bridges and tunnels to potentially allow areas where previously electrification was thought to be needed to be avoided. It is assumed that this would negate the need for route clearance in 75% of cases, saving approximately 15.4 million kilograms of carbon dioxide. However, some costs must be added back on, such as troughing and cabling to connect adjacent sections of discontinuous OLE and potential whole life carbon emissions of batteries. Batteries or another method of power may be necessary to allow trains to be powered when not under OLE. For instance, if an incident happens and a train has to come to a stop, it needs to have a way to move off again. The carbon emissions of troughing totals to 294,400.1 kilos of carbon dioxide, and the emissions of the XLPE cables used are not available, but it is highly unlikely that they will come close to the reductions made through the discontinuous OLE. One 4,800 kilowatt hour battery electric multiple unit emits 350,400 kilograms of carbon dioxide in its lifetime, Therefore, the reductions made could be used elsewhere to retrofit 55 diesel trains with batteries. So the third scenario I looked at was the use of low carbon copper conductor wire. And while it may only be a small improvement, it is still an improvement. It is a wire supplied by Elka Wire and would replace the current contact wire that we use. And they have an environmental impact assessment on their website. The wire uses very efficient ore concentration processes and a world-class green energy mix to allow for a saving of 150,000 kilograms of carbon dioxide emitted per 80 single track kilometers. And while it may be a less economically viable option, this reduction could be as easy as literally just changing a supplier. So where we get our wire from now, moving over to Elka wire would cause this huge reduction in emitted carbon dioxide. There were some scenarios that I looked at which seemed to have a bit of a negative outcome. So composite masts made of carbon fiber reinforced polymers. There wasn't enough data to accurately calculate carbon emissions of CFRPs. Some values were given that CFRPs are 5 times more energy intensive to process than steel. Some said 15 times more energy intensive. If the latter values are true, CFRP masts would need to be 15 times lighter than steel to make it worth using them to allow more to be transported at once and avoid transport emissions. CFRP is not able to be recycled at the same extent as steel either, so the processes used are either far more expensive or will yield very poor recyclability. Another negative scenario I looked at was the in-house component manufacture. So essentially bringing in materials to manufacture components in the UK to avoid overseas transport emissions for components. However, the materials to make components must still travel from their origin, so it doesn't make too much of a difference whether it's built outside or inside the country. You would still need to transport things somewhere. Also, if in-house component manufacture was adopted, there would be an increase in UK emissions due to the production of the components, and therefore I thought it would provide more of a detriment than a benefit. So here we have some of the break-even points. Now the break-even point for each scenario has been given as a graph here. They're utilised to give an approximation of the timescale required for the reduction in carbon dioxide emitted via electrification to outweigh the carbon dioxide emitted by diesel trains. So the baseline shows a break-even point of roughly 10 years in the future for infrastructure commissioned this year, with the crossover occurring in approximately 2035. This not only provides a reasonable assessment of how electrification will bring carbon costs down to approach net zero, but also that it can be majorly reduced in a relatively short span of time. The route clearance one on the top right, the break-even point for the route clearance scenario is slightly earlier than the baseline, occurring in approximately 2033 to 2034, showing a positive reduction in carbon emitted in the initial construction and also a lower total emitted carbon by 2050. The discontinuous OLE, bottom left, this shows a massive reduction in the break-even point, approximately 5 years earlier than the baseline, leading to a significant overall reduction by 2050. This would cut the break-even point in half, meaning a much quicker long-term carbon saving. This graph is shown without the emitted carbon from battery electric multiple units, as they are outside the scope of the study, but this carbon dioxide emitted should still be considered. And then in the bottom right, we've got low carbon copper conductor, and it looks like on the graph that it doesn't produce that big of a reduction in time for the break-even point, but it is, as we saw on the last few slides, still a reduction. So using it alongside another form of carbon reduction would make it even lower. Say you used low carbon copper conductor alongside discontinuous OLE, that would push further than if you used one or the other. So some of the conclusions I came to through this project was to reuse track that is removed during track lowering. This will save approximately 3 million kilograms of carbon dioxide emitted. Discontinuous OLE would save approximately 19 million kilograms of carbon dioxide, and low carbon copper conductor wire would save approximately 150,000 kilograms of carbon dioxide. These values are all linked to the 80 single track kilometers. So across the board, depending on how much electrification takes place, this could be a serious amount of carbon dioxide saved. The composite masts, it's very difficult to tell. It's a bit of a grey area. it seems unlikely that there will be great, if any, benefit, and the use of in-house component manufacture is more likely to increase carbon emissions than reduce them. And then finally, I just have some recommendations for the industry. So the study of composite material production greenhouse gas emissions needs improvement to define an objective value for carbon for each of the modules. It may also be appropriate to investigate the use of varying OLE types, such as an auto tensioning system versus a manual tensioning system. There should be extra study on the carbon content of lithium-ion batteries, allowing more accurate data on the exact carbon emitted by retrofitting diesel trains with battery systems. And it is necessary for more suppliers to list carbon data sheets on their products to ensure that it is possible to keep track of emissions as the UK approaches the deadline of achieving net zero. Thank you very much for listening.
That was great. Thanks, Matthew. Right, that opens us up then to the floor then. Do people want to ask any questions on those very insightful and very great presentations? Hi, Brian. Go ahead, Brian.
Yeah, no, well, firstly, thank you. Excellent sway, Shukri. Matthew, really good, actually. And yeah, I'm not sure if I cast my mind back as far as it was when I was a year in industry student, I had anything like those skills, and certainly not very keen presenter like that. So excellent, well done, really good, particularly with a bit of a virtual audience, which is difficult, and the threat of recording hanging over you. A couple of questions, one generally to everybody. Anything you'd really want to do, or you think you've missed out on, or would like to try and do in the last 4 months? Is there any sort of, actually, given half the chance, is there something we can arrange or help you achieve, a visit or something that you'd desperately like to do? If you want to go and do a great big presentation to a conference in front of hundreds of people, I wouldn't recommend it, but if you're that inclined, I'm sure those sort of opportunities can come up. But I just wondered, yeah, did any of you have any sort of showstoppers? And my second question, I'll let you have a think about the first one, was really to Matthew, a fascinating insight. Particularly, I hadn't thought about discontinuous OLE, but does that mean we could have gaps in the OLE where we've got awkward structures? So we're not having to lower the track. Is there a risk we run the pantograph and rip it off on the first bridge we come to because the wires stop just before it? But is that a real opportunity to avoid things like track lower or bridge reconstruction just by having some carefully positioned gaps in the OLE?
Yeah, so I'll go into that first.
Yeah.
So it was something that I'd been quite keen on from when I took on the project. I just thought that having a gap in the OLE in a situation where you'd have to make some serious adjustments for it would provide you with that serious reduction in carbon. The logistics of it, I won't lie to you, I haven't looked in to them in great detail. It would definitely have to be something that was looked at before, or if this went anywhere. But it's I do think that it's one of the best ways that we can avoid sort of killing the environment as we're electrifying, even though electrification is meant to save. So it would seem counterintuitive if we didn't, if that makes sense. Yeah,
no, absolutely. It was certainly from the sort of CO2 payback, it was vastly improved over any of the other options that you'd looked at there. So, fascinating. It's one thing I can go and nag Mr. Doty about, or my colleague, Mr. Stainton, over.
Oh yeah, that was who I did it with, Richard Stainton.
Excellent.
Yeah,
I shall go and bend his ear a bit, because it is always a last resort from my point of view, having to lower track under a structure. Yeah. It never lasts well. It's never good to maintain. It's never a good long-term solution, but it might be the cheapest option. But yeah, it's always a struggle. But I could see a lot of pantographs hanging off the front portal of bridges if we didn't have a very clever way of controlling them. So thank you for that. But back to the first one. Is there anything sort of any of you'd like to really try and do in your last few months?
Sorry, Sway, go on.
No, go on. I feel like you were.
I feel like we might say the same thing. One thing that's been talked about the whole year that we have all really wanted to do is to go and see the Forth Bridge, because there's been talks of it happening in the last few years that you've had year in industries, but the timings haven't seemed to work out for us yet. But that would be really, really cool.
Sound.
Okay.
We'll put that on the list.
Yeah, absolutely.
To be fair, I wasn't actually thinking about that, but that is definitely one. Now that
You can have two
mentioned
goes there, Sway. Yeah.
So really great question, given that although we've got an entire year to jump into whatever we want, it is a really short amount of time. It has
it goes
zoomed
really
by
quick.
really quickly.
Yeah.
And something that I sort of realized when I was doing the work experience session with the year 12s, although the sessions for the senior with the senior engineers were catered specifically for the students, I learned a lot, because at that time I was probably about 6-7 months in. Even now, there's no way that I can know as much as the senior engineers, at least sort of like what they were explaining. And one of the sort of things I wanted to do from that is potentially do like a 2-week or maybe a month's placement in a completely different division. I'm doing civil engineering and now I'm in the structures team. Let me switch it up entirely and go into contact systems and go into signaling, something completely different, to get that broad understanding, which we are exploring through the site visits and things, because they're not specific to our discipline. They are just general engineering. So it would be great to also do work in those other areas as well for a short period of time.
Okay.
Yeah, we can look at that as well.
Yeah.
Great idea.
Yeah.
Thanks, Brian. That was great.
No,
and
thank
great
you
presentation.
For the presentations. Yeah, absolutely.
Really good and insightful. Any and if there's anything else you need as well, please feel free to just drop us a line. Yeah.
Shukri, if you got a definite thing you really want to do, come and bend me ear anytime, or John Edgley's or whatever, and see what we can make happen from before you need to go back to college again.
Brilliant. Any more questions? No. I think that about covers it then, guys. Thank you very much for really insightful, different presentations as well. It's really great the way you all did them a bit differently and to a different angle, and more generalized in what you were doing, and then a deep dive. So really well done.
Absolutely.
Really well worked between you. So we'll look forward to next.
Yeah, more interesting hour than I had at some of my other hours earlier today. So yeah, full marks there.
100%. Yeah, totally agree. So thank you all, and if we could thank them in the usual way, and we'll see you in, I think it's our last meeting next period. Cheers all.
Absolutely.
Thank you very much.
Thanks.
Thanks.
Cheers all.
Appreciate it. Bye-bye.